In previous sessions, we tried to learn about some of the basic concepts related to the Earth-Sun relationship, and from this session onwards, we shall try to look at some of the concepts related to the planet Earth itself in order to understand it and its surface features in a more scientific manner. Look at this particular question given now. The first statement says that the parallels and meridians that define the geographic directions are same as latitudes and longitudes respectively, and the second statement says that the shortest distance possible between Arctic Circle and North Pole is slightly more than the shortest distance possible between the Tropic of Cancer and the equator. And given this particular statement, these two statements have to be understood conceptually in order to answer them. Those who want to attempt this question, please pause the video and attempt the question. And those who have found the right answer, you are really good at the concepts. Now we shall look at what are those concepts lying behind these two statements. If you look at the first statement, it gives you four very important expressions: parallels, meridians, latitudes and longitudes. Are they one and the same is what the question is asking. In order to understand this, primarily you must know that the Earth has a peculiar shape, as we have understood in the second session itself. It has a shape which is called as exaggerated geoid. That means whatever the rotation of the Earth over its axis is occurring, it is producing a particular shape because of the bulging that happens at the equator because of this rotation. And hence the actual shape that we get resembles not that of an exact sphere but of an applied spheroid, or if you apply all the various forces that are applicable on the planet Earth, it gives you a shape called as exaggerated geoid. Number one. Number two, because of this particular shape we find certain difficulties, and this difficulty is particularly with respect to positioning of related to the positioning of certain surface features, because there is no particular reference point. There is no particular reference point on the basis of which one can measure the relative positions of other points that you can find on the surface of the Earth. Hence, there is a difficulty in understanding the surface features of the Earth in a scientific manner in terms of their positioning first of all. This is where we started looking at having some network of imaginary lines that is drawn on the globe, or whatever that has been drawn on the globe in terms of these imaginary lines, that has to be presented on a flat sheet called a map, such that one can locate various places. This is what made us to draw these lines which are imaginary in nature. However, even to draw these imaginary lines, one must have some basic understanding, some basic point which is available scientifically, such that these lines can be drawn. This was possible because of the Earth's rotation itself. We know that the spinning of the Earth on its axis from west to east provides us two fundamental and natural points of reference. These 2 points are called as North Pole and South Pole, and hence the axis passes through these 2 poles and it provides you the fundamental natural points of reference. So they form the basis for establishing the entire network of these imaginary lines, and these imaginary lines, whichever have been drawn, are drawn in terms of 2 sets. One is horizontal lines and the other is the vertical lines. These horizontal lines are called as the parallels and the vertical lines are called as the meridians. Here, whatever the line which is being drawn, or whatever the circle or circular plane whichever is drawn on the surface of the Earth, going perpendicular to the axis which is there from north to south, going perpendicular to it in the east-west direction, is called as the equator. This is a parallel which is drawn perpendicular to the axis, and this circular plane which is drawn going through the center of the Earth is called as equator, because it divides entire Earth into the northern hemisphere and southern hemisphere equally, 2 equal halves. And remember, whatever the circular plane which passes through the center and divides Earth into two equal halves is called as a great circle. However, you will find the possibility of only one great circle which goes through the center of the Earth, but at the same time it is perpendicular to the axis of the Earth, and that is named as equator. And this has been formed as the basis for drawing the entire other parallels which are drawn on the surface of the Earth. And you can also draw number of other circles which are very small, cutting through the various portions of the Earth, and these small circles which are created when a plane passes through the Earth but does not intersect the center point of the Earth are called as small circles. So this figure clearly explains you what is a great circle and what is a small circle. There can be number of great circles, there can be number of small circles. However, this great circle which passes through the center of the Earth and which is perpendicular to the plane through which the axis of the Earth is passing through is called as equator. There is only one possibility, and hence it is called as equator because it divides Earth into two equal halves. And there are number of other parallels which are smaller in size in proportion to their distance from the equator towards the poles are also drawn, and they hence divide the Earth into two equal halves, which are also, as I told you, referred to as small circles. And these imaginary lines running east to west are commonly known as the parallels. So there are number of parallels that you can draw. Apart from this, there are number of vertical lines running north to south which join at the poles, and they are called as meridians. Remember that they are spaced farthest at the equator. They are spaced farthest at the equator, and by the time they reach the poles, they are joined there and they converge at this particular point, and whenever they converge, they form the poles. That means these vertical lines are converging at poles and they are spaced farthest at the equator. These pictures give you the pictures of the parallels and the meridians. If you look at this particular picture, meaning together they are forming what is called as geographic grid. When you draw these two lines together, they give you what is called as a grid. This grid is the way to depict the Earth or the globe on a flat surface in order to understand the surface features with respect to a reference point and its location. Number one. Number two, and this grid is possible because of whatever the imaginary lines in terms of parallels and meridians which are drawn. Number three, when I said that they are moving in east-west direction or they are being drawn in the north-south direction, remember that meridians and parallels have a particular function. They define the geographic direction. When meridian defines the north or south direction, parallel defines east or western direction. So infinite number of parallels and meridians can be drawn, and this every point on the Earth has a combination of one parallel and one meridian, and it is defined by their intersection. This is what the parallels and meridians have to do in terms of their function. Then what is latitude and what is longitude? Remember, latitudes and longitudes are commonly referred to as geographic coordinates. Where earlier we said that the parallels and the meridians intersect and they provide you the location of the particular point on the surface of the Earth, latitudes and longitudes give you the geographical coordinates of that particular point, and as they provide you the systematic network of lines upon which the position of various surface features of the Earth can be represented, they give you the scientific representation of the location. So with the help of these coordinates, there are three things that we do. Number one, location. Number two, distance. And number three, direction. And this is how the latitudes and longitudes give you more amount of information or scientific information than the parallels. What is this latitude of a particular place on the surface of the Earth? The latitude of a place on the Earth's surface is its distance north or south of the equator measured along the meridian of that particular place as an angle from the center of the Earth. to keep this point very simple, remember latitude is the angle between a point on a parallel and the center of the earth and a point on the equator. Let us look at this particular statement in terms of this particular picture which is being seen. In this picture, I am looking at a particular point here, which is the point of interest, number 1. Number 2, and that particular point, remember, will pass through its own meridian, and this forms its meridian. Number 3, remember that I am trying to have the shortest distance possible from the surface of the center of the earth, and this line represents this shortest distance possible. And you also know that this meridian cuts across the center line called equator, and this forms a point of reference again. So whatever the angle which is being formed here between these two lines, the line which joins the point of interest with the center of the earth and the line which joins the intersection of this meridian with the equator along with the center of the earth, whatever that angle which is being formed, it is called as latitude. So the latitude is clearly the angular distance, and we find that there are number of points on the surface of the earth which have the same angular distance from the center of the earth with respect to the equator, and all those points which are having the same angular distance are joined together, and this gives you what is called as parallel. And these parallel which joins all these latitudes, that is the points which are having the same angular distance, are called as parallels of latitude. This is how the parallels are drawn on the surface of the earth as imaginary lines. Number 1. Number 2, if you observe the parallels that are drawn in its entirety, you find that they vary from 0 degrees to 90 degrees. And why this is being seen? You observe that the circumference of the earth together, if I look at it in terms of a circular circumference, it traverses 360 degrees. That means if I start at a particular point called as North Pole, and if I have to complete one complete circle, I have to travel 360 degrees as the angular distance to reach the same point again. And if I am already drawing the central circular plane which is referred to as the equator, and if I have to draw parallels here, or if I have to find latitudes of various points, that means I am starting at what is called as 0 degrees here, and if I have to travel to this particular point, I have to travel 1/4 of entire circumference that I have, that is 360 degrees, and hence this 1/4 of 360 degrees is 90 degrees. And because of this, we find that the latitudes are being pointed only with 0 degrees and ranging up to 90 degrees. So 0 to 90 degrees is the range that we find for all the parallels in both the hemispheres, southern hemisphere and the northern hemisphere. If such parallels of latitude are drawn at an interval of, let us assume 1 degree, at an interval of 1 degree, there will be 89 parallels in the northern hemisphere and there will be 89 parallels in the southern hemisphere each. So the total number of parallels that can be drawn, thus including the equator, will be 179 only, but not 180. Remember this. Depending upon the location of a particular feature or place of Earth, north or south of the equator, the letter N or the letter S is written along with the value of the latitude. Remember that if the Earth were to have a perfect sphere, the length of each of the latitude, that is a 1 degree latitude arc of a meridian, would be a constant value, and if you calculate this, it will be around 111 kilometers everywhere on the Earth. However, this length is not, as we find, constant, because we find that a degree of latitude changes slightly in length from the equator to poles because of the rotation of the Earth. We know that Earth gets elongated at the equator and it gets a little bit bulged at the poles, and when it gets elongated at the equator, we find that the distance between each of the latitude gets reduced. However, the same level of reduction will not happen at the poles, and hence the distance between two latitudes at the poles and two latitudes at the near the equator is not the same. At the equator you find that it is at 110.6 kilometers, while at poles it is at 111.7 kilometers. However, in terms of constant, we find that each of these 1 degree latitude distance from the equator or at the poles, whatever the distance that we find between each of these degrees of parallels of latitude will be taken as 111 kilometers as a constant approximately. Latitude of a place may also be determined, as you know, with the help of what the altitude of the sun or the pole star that we have understood in the previous session. Remember, each degree of these parallels or latitudes can be further divided into minutes and seconds. 1 degree will be the 60 minutes and each minute will be 60 seconds, such that the precise location or the precise positioning of a particular location can be obtained. Now let us look at what is this longitude. The longitude of a place as it is defined is its angular distance east or west of the prime meridian. You know that prime meridian is a point which goes through this Greenwich as a location, and it is measured in terms of 0 degrees. And remember that the longitudes vary from 0 degrees to 180 degrees eastward or westward of the prime meridian, because the part of the earth east of the prime meridian which is called as eastern hemisphere, and the part of the earth which is lying west of the zero meridian is called as western hemisphere. And in order to join these two on the circumference of the earth, one has to travel 180 degrees, because the entire circumference is 360 degrees and half of this will be 180 degrees to join each of these poles, and meridians being the semicircles which combine each of these poles on the surface of the earth, and as they form these semicircles they have to be 180 degrees, and hence you find that all the longitudes have been placed from 0 degrees to 180 degrees both eastward and westward of the prime meridian. And unlike the parallels of the latitude, as I told you, which are circles, the meridians of longitudes are semicircles because they have to converge at the poles. And if opposite meridians are taken together, you find that they complete a circle, but they are valued separately as two separate meridians, because converging at poles is what ends the distance of the particular meridian. Number 2, the meridians also intersect the equator at right angles. Unlike the parallels of latitude, they are all equal in length, and for convenience of numbering, the meridian of longitude passing through the Greenwich Observatory, as I told you, has been adopted as the prime meridian by an international agreement, and this has been given the value of 0. In simple terms, let me look at this longitude. Suppose I have a particular point here. I want to measure the longitude of this particular point. What I'll try to do is, I'll try to draw a meridian which is connecting the pole with the point at which I am interested. When I am drawing a meridian, it goes like this and it cuts the equator at a particular point. And now I am also interested at this 0 meridian. It is also cutting the equator at another particular point. So the longitude is the angle between the point of my interest, which is having a meridian which is cutting this particular equator at a particular point. Let me assume that it is P, and the angle and the point at which the 0 meridian is also cutting the equator, and whatever the angle which is being formed at the center of the earth is called as longitude. So this particular meridian will have this particular angle, and if let me assume that it is 60 degrees, then this is called as 60 degree meridian. And this particular meridian can also be divided further into minutes and seconds, as we have done with respect to the latitudes, and it's of a point east or west of the prime meridian or Greenwich meridian. Remember that the particular points which are lying here can be joined together, and these points when joined together, which are having the same angular distance that we are measuring here, in terms of these semicircles which are drawing, they form what is called as meridians. So we generally use these two expressions, parallels of latitude and meridians of longitude. So as we see in this particular picture, all these longitudes merge at these poles, and hence you find that the distance between degrees of longitude varies greatly depending upon the location on the planet, unlike latitude. So they are farthest apart at the equator and they are converging at the poles. And since the earth is spherical and has a circumference of 25,000 miles approximately, you find that the linear distance of each of these 360 degrees of longitude is 25,000 by 360, and which comes about 69.1 miles and gives rise to approximately 111.3 kilometers. So a degree of longitude is widest at the equator with a distance of 69.1 miles or 111.3 kilometers. The distance gradually shrinks to 0 as they meet at the poles. If you look at 40 degrees north or south of the zero meridian, you find that the distance between a degree of longitude is 53 miles or 85 kilometers. And this line at 40 degrees north, which runs through the middle of the United States and China as well as Turkey and Spain, and also if you look at this 40 degrees south, which is south of Africa, goes through the southern part of Chile and Argentina and runs almost directly through the center of the New Zealand, you find that their importance shrinks if I look at the distance of the longitude, and hence there is so much of difference in length of these degrees of longitude outside the tropics that they cannot be used for calculating distances, as we see in the case of latitude, where we use them for calculation of distances even beyond the tropics because of least differences in terms of distance, angular distance that we observe. Now if you look at the two statements which are given above, you find that the first statement, where the parallels and meridians that define the geographic directions are same as latitudes and longitudes, is wrong because of the conceptual difference that they have. And the second statement, whichever is given, that the distance, shortest distance possible between Arctic Circle and North Pole is slightly more than the shortest distance possible between Tropic of Cancer and the equator, is correct, because once we go towards the poles, the distance between the various parallels slightly increases, and once you come towards the equator, you find that within these tropics, because of the rotation of the earth, because of the phenomena of bulging of the equator, you find that the distance between each of the parallel gets reduced slightly in comparison with the parallels which are there above, and hence the second statement has to be correct, and hence for this the answer must be B. So beyond tropics, if longitudes are not used for calculating distances as in the case of latitude that we find, what is their important function then? Remember that they have very important function to do, and in fact the most important function to do of determining what is called as local time in relationship with the Greenwich Mean Time, which is also referred to as the world time. So finding this local time, world time and the standard time is what the meridians have to do as a function. We know that Earth rotates from west to east over its axis, and it makes the sun rise in the east and set in the west in terms of its apparent movement because of this earth rotation, as we have learned earlier. So the rotation of the earth over its axis takes, as you know, 24 hours to complete one particular circle or 360 degrees of longitudes. As 180 degrees of longitudes fall both east and west of the prime meridian, as we have understood earlier, the sun thus takes 12 hours of time to traverse its eastern and western hemisphere. So local time is the time that we obtain based on the noon at a particular location. However, if you recall, noon will be occurring at different time at different locations, and hence local times and for each and every meridian is going to be very, very different, and it is going to be different for each of the location on the surface of the earth. And we also know that there are certain other regions which will not have perfect noon in terms of having the solar radiation completely overhead during this noon period, and because of this local time is not a feasible phenomena to calculate in order to know time at each and every location of the surface of the earth. So in order to determine this, the time may be determined for any place in the world in what is called as world time. In this, what we do is the rate of the time at which the sun traverses over certain degrees of longitudes is used to determine the local time of an area. However, it will be determined with respect to the time at the prime meridian. With respect to the time at the prime meridian. Now, if I take into consideration the prime meridian, that is the 0 degree latitude, and if the time there is 12 noon, I will try to calculate the time for each and every longitude moving from there. The immediate next longitude, because of the calculation that we had here, that each and every degree must lead to an increase in the 4 minutes if it is lying on the eastern side of the prime meridian, then it will be 12:04 on the east of this side, and it is 11:56 on west of the prime meridian. Meaning, you must note here that the time decreases when we move from west to east, and it increases with our westward movement. Or if we move eastwards from west, there will be gain in time, and if we have the westward movement from east, there will be loss in time. So the rate at which the sun traverses over certain degrees of longitudes, which is used to determine the local time of an area with respect to the time of the prime meridian, that is 0 longitude, is called as world time. However, as we know that there is this difficulty of having a huge administrative boundary for any country, you cannot have the world time for each and every meridian which is passing through that particular country. And hence, in order to overcome this particular difficulty, we started looking at what is called as standard meridian, and this standard meridian starts giving you what is called as the standard time. So whatever is the local time at this particular standard meridian will be taken as the standard time for the whole country. Now look at this question. The first statement says that outside the tropics, longitudes are not used for calculating distances as in the case of latitude, which is the correct statement. Second statement, where it says that where world time denotes the local time in relationship with prime meridian, the standard time is determined by choosing the standard meridian within the administrative territory to determine the time within their administrative boundaries, which is also true. Hence, both the statements are correct. C is the right answer. Now I have something as homework for you. Please do this work. Try to identify the important latitudes in terms of the 23.5 degrees parallel, in terms of the 66.5 degrees parallel, and try to identify the continents and countries which lie on these particular parallels of latitude. And also similarly, try to identify the important longitudes and the continents and countries which lie on them, particularly 180 degree and the 0 degree longitudes. And also identify some of the important latitudes within the region of India, and try to identify some of the important cities or regions or states which lie on these latitudes, along with the meridian, which is 82 degrees 33 minutes east, which is the standard meridian for calculating Indian Standard Time. Do this homework, which are very important for the examination.